Good evening to all. This is Dr. Upendra, Assistant Professor of Chemistry, Government Degree College, Ayatnagar, Rangareddy District, Telangana State. So now, structural theory in organic chemistry discussed today. So already two reactions are discussed. So remaining two types of reactions, those are addition reactions discussed in this class. So those are free radical substitution reaction. So two reactions are discussed in the substitution reaction. So one is electrophilic substitution reaction on nitrobenzene. So second one is nucleophilic substitution reactions in alkyl halide. So third one is free radical substitution reaction. So free radical is the reagent in the reaction. What is the free radical? So single electron space is the free radical. Those are paramagnetic space. So one radical is substituted by other radical. So odd electron group or atom. So simply chlorination of methane. So saturated compound methane. So alkanes undergoes free radical substitution reactions. So in the presence of light. So you take here simple alkane methane. So with chlorine in the presence of light, you will get chloromethane or methyl chloride. So the reaction mechanism undergoes in three steps. So one is the chain initiation, chain propagation, chain termination. Free radical substitution reaction takes place in three steps. So chain initiation, chain propagation, chain termination. So chain initiation, here radical is the initiator. Chlorine molecule homolytic fission takes place in the presence of light. You will get chlorine radical. It is the initiator. Active space in the reaction, chain reaction. So propagation means it is the development reaction. This chlorine radical attacks on alkane, simple alkane. You will get here methyl radical. This methyl radical react with the chlorine molecule. Again you will get here chlorine radical. This chlorine radical again involve in this step, first step. So this chlorine radical involve in first step. So you will get methyl radical again react with the chlorine molecule. You will get here methyl chloride and chlorine radical. So similarly takes place A and B and A. So chain development takes place in the second step. So it is called propagation. So methyl radical is the active space. This active space chlorine molecule homolytically cleave. You will get methyl chloride and chlorine radical. This chlorine radical involved in first step. You will get methyl radical. This is the chain process takes place in second step. So what is the meaning of termination? Any two radicals add, you will get neutral molecule. That is called termination. Chlorine radical. Two radicals give chlorine molecule. So methyl radical, chlorine radical. Two radicals always produce neutral molecule. This is the radical substitution reaction or free radical substitution reaction. So addition reactions are three types depend on reagent. Already you know very well three types of reagents present in reaction mechanism. So one is electrophile, second one is nucleophile, third one is radical. The reaction in which the reagent or substrate combine together to give a single product is called addition reaction. So like substitution reactions, addition reactions also explained mechanism very detail. So sorry. So electrophilic addition reaction. Simply an addition reaction is initiated by electrophile. So electrophile is the initiator in addition reaction. Electrophilic addition reaction takes place in alkene and alkynes. Unsaturated compounds undergoes electrophilic addition reactions. Those unsaturated compounds will convert into saturated compounds. So, for example, you will take here ethylene molecule with hydrobromic acid, you will get ethyl bromide. It is the unsaturated compound changed into saturated compound with the help of HBr. With the help of HBr. So, this is addition takes place here. So, how do you takes place? You will understand with the mechanism. So, for example, you will take HBr ionize into H plus and Br minus. So H plus is the electrophile. H plus is the electrophile. So why electrophile takes place first? So what is the reason here? Ethylene or alkene act as a nucleophile. So pi bond is there between two carbons. It act as nucleophile. Nucleophile wants electrophile. So you will get here ethyl carbonium ion, ethyl carbonium ion. This carbonium ion again combined with bromide ion. So you will get ethyl bromide, ethyl bromide. So electrophile is the initiator here, starting space. So it is called electrophilic addition reaction. Electrophilic addition reaction. If reaction start with nucleophile, that is called a nucleophilic addition reaction. Nucleophilic addition reaction. So second type is nucleophilic addition reaction. Nucleophilic addition reaction. So nucleophilic addition reaction undergoes in carbonyl compounds. So nucleophilic addition reactions are not discussed here. So slide is so the pre-radical addition reactions. Second, pre-radical addition reaction. An addition reaction is initiated by pre-radical. So the reaction takes place in the presence of peroxide. So without peroxide, that is electrophilic addition reaction. Without peroxide, that is electrophilic addition reaction. With peroxide, that is pre-radical addition reaction. So peroxide is the catalyst here. So in the presence of peroxide, you will get radicals. Whenever you use light or peroxides, you will get radicals. For example, you take here propane with HBr in the presence of peroxide R2O2. You will get 1 bromopropane. So peroxide first homolytically cleavage takes place. So mechanism homolytically cleavage takes place. Alkoxy radical. So this alkoxy radical react with HBr. So yeah, in the presence of radical HBr bond homolytically cleavage takes place. Radicals produce H radical, Br radical. But H radical react with RO radical. Alcohol will get. So bromine radical is our active space. It is our intermediate bromine radical. It is radical mechanism. So bromine radical first react with propane molecule. One propane molecule, you will get a secondary radical. Secondary radical is more stable. So again alcohol react with the secondary radical. So you will get secondary 1 bromopropane and alkoxy radical is the byproduct here. So it is called anti-Markovnikov law. As per anti-Markovnikov law, peroxide product formation takes place in the presence of peroxide. Anti-Markovnikov law, what is the meaning? So radical or negative space alkyl halide ion or halogen add at the carbon which is having more hydrogen, so halogen had at more hydrogen site, so that is called anti-Markovnikov law. So anti-Markovnikov product formed in free radical addition reaction. So this is the radical mechanism. So I hope you will understand very easily. So without peroxide, that is electrophilic addition reaction. With the peroxide, that is free radical addition reaction. So in this case, radical is the initiator. So it is called free radical addition reaction. Free radical addition reaction. So